So today we're talking about objective 36, the solving linear systems of equations by substitution. So consider the following two equations. Y equals 3, 2x plus 3y equals 5. We want to solve for x. So using substitution, we can actually know that y is equal to 3 in this problem. So we're going to actually substitute the 3, which is equal to y, in the second equation, because we know the value of y is 3. So we're going to rewrite 2x plus 3, and we're going to take out the y. So when we take out the y, we're going to put in this 3. And then we're going to write equal to 5. So now you can see we have an equation, 2x plus 3 times 3 equals 5. So we can just use our linear algebra skills to solve this. 2x plus 9 equals 5. And we would subtract 9 to both sides. We get 2x equals negative 4. And then we would divide by 2. And lo and behold, we would get x equals negative 2. So in this problem, x equals negative 2. What if you had something more difficult? In problem A, we have y equals 2x plus 1, and we have 2x plus y equals 5. We're going to do something similar. We're going to take out 2x plus 1 is now equivalent to y, so we're going to replace the y with that value. The reason we're doing this is that we want to get an equation with one single variable. We want all x's in this problem. So you can see I took out the y, replaced it with the expression 2x plus 1. Now we're back to algebra, combining like terms, and solving. So we get 4x plus 1 equals 5. Then we're going to subtract the 1 to the other side. We get 4x equals 4, and then we'll divide by 4, and we'll get x equals 1. Now the question is, how do you find what y is? Because in a system from yesterday, graphing, we have to find the solution, which is x and y. So what we're going to do is we're going to take x equals 1, and we're going to replace it in either equation above. I'm going to choose to use the first equation because it's already set up for me. We have y equals 2x plus 1. So we're going to take y equals 2, and we're going to take out the x, and we're going to replace it with a 1. And then we have plus 1. So if you look at the top equation, everything's the same except for x is taken out. We've replaced it or substituted it with 1. Now we just simplify. 2 times 1 is 2, plus 1, so we get 3. So our final answer is x is 1, y is 3 as a coordinate. Part B. Part B is a little more difficult because we have x plus 3y equals 8. That's standard form from your algebra class. And 2x plus 4y equals 14. That's also standard form. So unlike A, where we had the first one in slope-intercept form, it was much easier to substitute. We're going to have to be a little more creative. So I would take the first equation, and I would subtract 3y to both sides. So we get x equals 8 minus 3y. Then what I would do is I would take, since x is isolated, I would take the 8 minus 3y and substitute in for x. This is a very important step that students that often start substitution for the first time. The variable that you substitute for in the second equation is dependent on which one you isolated. We isolated x. Remember, isolate means take alone. So we are going to take out that x and plug in an 8 minus 3y when we get to our equation. So we have 2, and we're going to substitute 8 minus 3y. And then we're just going to copy down the rest of the equation. So now you'll remember that we have to use the distributive property. So in algebra, we have to distribute the 2 onto 8 minus 3y. That's going to give us 16 minus 6y plus the 4y equals 14. Now we can combine like terms. So we have 16 minus 2y equals 14. We subtract 16, because those are the like terms. We're going to get negative 2y equals negative 2. Divide by negative 2. And we get y equals 1. And again, we want to figure out what x is as well. So we're going to go up to either any equation you want. I'm going to go up to this equation up here, because x is isolated. And I'm going to substitute in for the y. So x equals 8 minus 3. Take out the y, and plug in a 1. Now I can do the math. I have x equals 8 minus 3 because the 1 is irrelevant. So I get x equals 5. My final answer would be 5 comma 1. Remember, we always write x comma y and use parentheses to indicate coordinate system. So below is a summary of the procedure that we just did. You could pause the video if you want and read this. I'm not going to read it word for word, but it's basically summarizing what I taught you above. There's some special scenarios that we need to talk about. So 3x plus y equals negative 4, 6x plus 2y equals negative 2. I'm going to solve this one a little more quickly than I did on the previous ones, but I'm going to isolate the y. So in the top equation, I'm going to subtract 3x. So I'm going to get y equals negative 3x minus 4. And then I'm going to substitute in the second equation. So I have 6x plus 2. I'm going to take out the y and plug in minus 3x minus 4. So I'm taking that and substituting for y in the second equation. And now I'm back to distributing. So I have 6x plus negative 6x, because remember you're distributing, minus 8, that's 2 times negative 4, equals negative 2. I combine like terms. The 6x's are going to drop off. I'm going to get negative 8 equals negative 2. I could add the 8 to both sides if I want, combining like terms, but then I'm going to get 0 equals 6. Does 0 equal 6? That doesn't make any sense. So in this scenario, something's wrong. What we have to look at, if you look back at this problem, y equals negative 3x minus 4, if we were to think about graphing that, we would go down to 4, then down 3, right 1. The slope is negative 3. If we take the second equation over here and we isolate, very quickly, we isolate the y variable, so we basically put it in slope-intercept form. We get y equals negative 3x minus 1. So that would be negative 1, down 1, 2, 3, right 1. No, drawing's not to scale, not perfect. This also has a slope of negative 3. These lines are parallel, they'll never intersect. So if you ever solve a system of equations and it doesn't make sense, it basically means there's no solution, because 0 cannot equal 6. Something to keep in mind if you're moving forward, you don't recognize that they're parallel lines. Another example, I went ahead and gave you y equals negative 2x plus 1 and negative 8x plus negative 4y equals negative 2. So we substitute negative 2x plus 1 in for the y variable in the second equation. We'll have an equation that looks like this. Negative 8x plus negative 4, negative 2x plus 1, that's this, equals negative 2. And we distribute, so we got negative 8x, distribute, positive 8x, negative 4 equals negative 2. Again, negative 8x and positive 8x are going to cancel. Sorry, I just realized I made a mistake. I want to change this problem above. Instead of having it equal negative 2, I want to have it equal negative 4. So then down here, I'm going to have that equal negative 4. My apologies. So all I did was change this second equation. So when you do this problem, the algebra doesn't change. The system doesn't, the method doesn't change. But the negative 8x and 8x will still cancel. But now, look, you get negative 4 equals negative 4. So in this example, it's a true statement. This makes sense. So what happens here? Well, if you graph these lines, negative 2x plus 1, so you go up to 1, go down 2, right 1, so you have y-intercept of 1 and a slope of negative 2. Well, negative 8x minus 4y equals negative 4. If you graph that line, if you isolate it, it's going to be the exact same line. It's going to lay on top. It's basically going to lay on top of this line. So these two equations, at first glance, look like two different equations, but they happen to be the exact same equation. So when they're the exact same equation, we would say that this system has infinitely many solutions. Infinitely many, because they intersect everywhere. Infinitely many solutions. So it's another special case to remind yourself of. Good luck on your homework.